Oh, creo que ya le di. Ok. Hello. Hello, good morning. Well, actually the camera is a little bit off. Yeah, it's a little bit off. Well, I just wake up like half an hour ago, 37 minutes ago. And yesterday I was up late because I overslept on the afternoon, yesterday's afternoon. But I was still learning Python. So the idea today is going to continue learning Python. But first, let's open the Pomodoro app. You know, so I'm trying um, to basically speed up my learning process, and my strategy here is to dedicate more time to the activity. So that's basically it. So what we're going to be doing today, well, first let me share on social media. Okay, Twitter and LinkedIn. Those are my main. Well, my real main is going to be Twitter. I'm posting things on LinkedIn, but I'm not really interacting with anybody there yet. I want to be ready before that. Is comfort is part of understanding truth. Is supposed to make you come on. I put that one. Ouch, that's a lot of money. Wow, that's a lot of money. So basically, I can buy a house with that money. At least in Mexico, I can buy a house with yesterday's money. Anyway, there's a bot there. Okay. Whoa, that's a lot of money. What? No. Wait, what? Anyway, I'm getting distracted. So, okay, I already had an S. I'm getting distracted with Twitter. Let's move away from that. I should have prepared for this. Okay. Okay, never mind. Well, let's see where were we. Let's change to the laptop that you are being seen the entire time. Oh wait, no. Before that one, I actually need to open up the Pomodoro app. That I forgot about it. There we go. Are you getting somewhere? Okay. Okay. So let's put the phone to charge. And there we go. So looks like we're ready to begin. Now. Oh. There we go. So. Okay. So last time we were watching how to send emails. During that time, I believe that I catch on Google is no longer going to allow third-party apps to basically do this, send an email with their accounts. So I don't know if they are going to allow other people or third-party accounts to send email via APIs, maybe. I don't know. Huh, okay. My God, look at this. I want to know when was the last time I put that there. Never mind. Well, I wonder if I can actually send email. But I don't know. Let's rewatch this one here. Oh wait, security. On these notes, there we go. It's been mentioned here. Well, the thing I could do is try out the code. Oh no, wait.
Welcome back. We want to improve our program so that instead of just sending a generic email like this, I want to customize it to each individual. Imagine if we have a database of all these users, all their emails, as well as their first name. Ideally, we're able to customize the email to each specific person. So how can we do that? Well, we're going to use an HTML-based email. So we can send text emails, which just have text, like we've seen, or we can send something more dynamic, like
I
HTML.
had done that before.
This is an HTML course, and it's something that we'll go into a little bit more in depth when we talk about web development. But in here, I have a very, very basic HTML document, and this HTML document just has a body where we want the content of our email to be. Now in here, I wrote, you just won so much money. And then with a $ name. You can write whatever you want in here, but I want you to pay attention to the $, because we're going to do something unique. We're going to actually update this to reflect a variable, a Python variable that we can substitute and customize dynamically. Now, how are we going to do that? Well, if we go back to our email, I want to introduce you to two new packages, built-in packages in Python that we can use. One is called the template, or string template. So from the string module, we can import template. And what this template does, if we go to the documentation, right here, we have a string.template class. And what we're allowed to do is, as you can see here, using
Python library,
we can substitute variables inside of text.
Whoa, what?
Here, if we zoom in a little bit, we have a template object with who likes what, and we can substitute these $ D with who. So who equals to Tim. We can do template who likes what equals to S, and then substitute who with Tim and what with Pow. So this is going to be very, very useful. And this is what we're doing with index.html. We have a $ name, and ideally we're able to update it.
Wait, but like 2 weeks ago, I watched this video about PyScript on HTML, and they basically allow you to use Python variables inside HTML using scripts. So, well, this video is outdated, so I guess this is why the library needs to exist.
But we have a problem here. This is it's an HTML file. It's an index.html file. So how can we read this, convert it to a template, and substitute it? Well, we have another module that we're going to import. And this is going to be called pathlib from path.
Oh, I've been using that.
So this pathlib and this path that we import is actually very similar to something we've seen before, which is os.path. So we could have also imported the operating system OS module and used the path method, because what it allows us to do is to access this index.html file.
I've been using that, actually.
We can have an HTML variable that equals path, and then give it index.html, because we're in the same folder. And this path now gives us access to index.html, and we can use the read text method on it to read it as a text, as a string. Now, I'm going to leave a resource as to why we want to use pathlib instead of os.path, mainly because we have this read text method.
Yeah.
But there's a great article here, why you should be using pathlib versus the os path module that I'll link to and you can read on your own. At the end of the day, though,
I've been using pathlib anyway.
Useful, and there's no right or wrong, just pros and cons. So we have this string, but now we want to update so that the name variable will be something custom. So what we're going to do is wrap this in template. So it becomes a template.
It's going to become a text.
That's it. So we have this HTML that is a template. And if you remember, once we have this template string, we can use the dot substitute to give it, well, what we want to substitute.
Dot substitute on
so
HTML.
Content like this. Instead, I'm going to change this. And say, I want HTML dot substitute.
Substitute.
To equal name, which is, remember, the variable over here.
The variable.
To have it equal, let's go with Tintin. And by the way, this substitute can have multiple parameters. So we can do it with keyword arguments, or we can even do it
It's an args.
A dictionary, like this. So we can say,
it's a one.
Tintin, and then we can add multiple variables if this HTML file had multiple variables. Multiple, maybe name, age, maybe a greeting, whatever we want.
So it's a dictionary receiving a single argument.
And see if this works. I'm going to send once again. And this time around, I want to actually send it to my Gmail account. So we'll actually blur this out so you don't see my personal email address. All right. All good, boss. It looks like we didn't get any errors. Now let's check my Gmail account. Hey, look at that. Under important and unread. Mind you, for you might get it in your spam folder. I have an email for myself saying, hey, I just won $1,000.
But it's not rendering.
And the last thing we need to do when we substitute is we have to tell it, hey, this set content is going to be HTML. So the way we do that is in the second parameter, we say, this is going to be HTML. So it's not text like it was before. It's going to be HTML, so parse it accordingly and set content.
It's not parsing the HTML code.
And we run.
He just messed it up there.
Errors. That's good.
Okay.
And if we go back to the Gmail client, hey, looks like I have a message.
Now it's rendering as
really
an
Mind you, for
HTML
yourself, you might
page.
find this in your spam folder. So again, make sure you check your email. Otherwise, if I click on this, you just won so much money, Tintin. How cool is that?
Yeah, it's great.
So
actually,
like
it's really
we'll
simple.
Programmatically send emails, customized emails. Now, there's many applications of this. Maybe anytime a customer buys a product from your company, you want to send them a personal email, a greeting, saying, hey, thanks for buying our product. Or maybe you want to get yourself a reminder where every morning you send yourself an email saying, hey, get up and tidy your bed. There are so many applications. This is the cool part about Python, right? You can do anything you want. The world is your oyster. So hopefully this was exciting because we have a lot more in the next video. Bye-bye.
So he's moving out to another.
Hello.
Oh, wow. The mouse decided to die there. Okay. Okay, let's look for the project code. What's this? Oh, this was from yesterday. Okay. I don't think it's going to work because of the changes for security here. Okay. I wonder if this is working. No, it's still off. Never mind. I know they are working on it. I wonder if I've been banned. If I recall, in 2013, I was making maybe not a bot, but I was working with I was learning Linux Bash, very simple commands, and I managed to find a command line program that allowed me to tweet stuff. And I used it back then to tweet stuff and now to follow people. And maybe back then they banned me, but I don't really know. I don't think so. Because my account was never banned. Like eventually, like a month after that, Twitter announced that they were going to pin down bots that do precisely that. But I wonder if they banned me on the developer side too. I don't know. That's what I was asking. So I never got an email, and after a month or two, the program stopped working. So yeah. Okay, let's see. Thank you. You are going to save me a lot of time. Okay. Is the same code? Okay. Well, I'm going to save this. Well, I may like to try that outside the stream. Be right back. Yeah. I just want to make a quick test, and I'm not going to put my password here, but let me see. Okay. I may like to try that one and see if this works. Oh, wait, I'm missing files. Never mind. And it took some time and it didn't work. There we go. Okay, so I guess for this specific example and for, let me see. Oh, okay. For this specific example, I'm going to go back, just give me a minute. There we go. Now, okay, for this specific example, I got this error. It's not allowing me to open up this, but I got this page. So basically, I think that I can do that, but I need to rework how to actually sign in with add passwords. Add passwords aren't recommended and are unnecessary in most cases. So basically, I guess this video is outdated. Probably I need to download something more current. But anyway. And this is the steps to actually use it. I think that it's going to take me more time than expected to figure it out. And I'm not going to dwell too much into that because the last time I did that was with this, with Twitter API. And it got me nowhere. I was not able to make it work. And it took too much of my time. So I'm going to just skip this sending email thing. And I'm going to keep progressing with the password checker project. Okay, I'm going to be back. I need to go to the restroom really quick, and I'm going to be back. Okay, I'm going to leave you with some music, maybe. Yeah, let's not be an asshole. Okay, let's put some music in the background. There we go. I'll be right back. Okay, I'm back. Thank you. You're not needed anymore. I only had 6 minutes left. Wait, what? The clock was... Oh, never mind. It's okay. Oh, wait. Now. There we go. Oh, well, I got a t-shirt. Oh, by the way, I need to turn on my laptop from work and check out email because I've been way too focused learning Python lately, so I wonder why it's asking me to install the same thing over and over again. I don't get it. Now it's asking me for my password. Wait, no, cancel. Yeah, because this is a bigger number. Never mind. I don't know why it's asking me for this. This doesn't make any sense. Never mind. Okay. Now the next project is going to be a password checker project.
Oh, I'm super excited because this is my favorite project of the entire course.
Yeah?
In fact, I wish I could just do this over and over. I'm telling you, this project is going to wow you. Now, it's one of these projects that initially it doesn't sound that exciting, but I've included it in our course because I guarantee you talk about this project to an employer and they're going to be impressed with your knowledge. It's an actual tool that I use day to day for security reasons. And I'm really excited for us to build this together. By the end of it, I promise you, you're going to be extremely happy with it. Okay, maybe I'm a little bit overly excited about this kind of stuff, but hey, who knows? Maybe you will too. What we're going to build is a password checker, but not just any silly, dumb password checker. This is legitimately going to be the most secure way for you to check if your password has ever been hacked. That's right. So what's going to happen is we're going to be able to type in our terminal, Python 3, and then we'll have a check my pass.py file that we're going to write from scratch. And in here, when we run this program, we're going to be able to input any password that we have and check if it's ever been hacked. Now we'll get into how this works and how we know a password has been hacked in the next video, but just to show you how this works. If I say, let's say hello as a password, let's say if hello has ever been hacked, maybe password 123, and then a super tough password like this. So it's going to be able to check as many passwords as we list here. And if I hit enter, it's actually going to check these passwords. And we can see that hello was actually found, what is this, 253,581 times. So it's been hacked that many times. So you definitely shouldn't use this password. Password 123, as we can guess, yeah, you shouldn't use that password. What about this one, this gibberish password? This password has actually never been found. So you should carry on and use this password. Over the next couple of videos, we're going to build this tool, a tool that you can actually use in real life to check if your password is secure. Now, how does this work? let's explore that in the next video. Welcome back. How are we going to build this tool? How are we going to know what passwords have been hacked? What does it really mean anyway? Well, passwords get leaked all the time. We've heard about data breaches, right? Facebook has been hacked with that. Equifax, LinkedIn, Yahoo, all these big companies sometimes get their databases leaked. And essentially what happens sometimes is our usernames and passwords get leaked to the public. And hackers, what they do is they compile these lists of leaked usernames and passwords and essentially try to log into different services. So there are databases, or you can think of them as massive Excel files, of all emails and passwords that have ever been leaked throughout history. And there's actually a website created by somebody called Troy Hunt, who's a very famous security researcher. And it's called Have I Been Pawned? And what you can do here is you can actually enter your email address and say, let's go andy@gmail.com. Has this ever been leaked? Oh no, it looks like it's been pawned. So it looks like it's been pawned on 88 breached sites and found 27 pastes. What this means essentially is that this email has been part of a data breach. So maybe I used this email as my Facebook login. Well, when Facebook got hacked and some users maybe stole user information, well, this email was part of it. As a matter of fact, for 88 breaches. And if I go to passwords here, you can actually do the same thing about passwords. I can check my password, and you can see over here that it doesn't show, and I can click over here to see if it's been pawned. Now, I just enter some gibberish here, and it looks like, nope, no pawnage found.
No.
But why does this matter? Why do we care that emails and passwords have been leaked? Hackers use something called dictionary attacks. And a dictionary attack, well, kind of like a Python dictionary, uses a massive dictionary with the key and value of, let's say, a username and password, and just tries to log into websites using these massive lists of information. And if your username and password has ever been leaked, well, a hacker simply runs what's called a brute force attack, where it just loops through all these leaked usernames and passwords and tries to log in. So maybe going into Facebook and just looping through this massive list, eventually they're going to hit something and be able to log in. Now, here's the thing. This isn't a web development course. I mean, this course is about Python. And although we have a section on web development, what I can tell you is that most of the time, even though I trust this website, it uses something called HTTPS, which is encrypted, I or you should never really trust a website with your password.
That's asking for your password. Yeah.
But ideally, you don't want to send your password like this over the internet. Because what's happening here, as soon as I click this, is that it's being transferred to a server somewhere in the world. It's traveling through the internet wires, and somebody could.
And you don't even
so
know.
A more secure way of doing this, and this is what we're going to build. This website actually gives us a password API for us to do this and check our passwords, but in a more secured way. Because sure, we might trust this website, but the best security is to trust no one, right? Now, what I'm about to show you and what we're going to do is actually a technique used by legitimate password managers like Keeper, 1Password, you might have heard of, Blur, Sticky Password. These are expensive password managers that keep your password secure, but we're going to build that ourselves because we're programmers. So in the next video, we're actually going to start coding a bit and learning about this passwords API. I'll see you in the next one. Bye-bye. All right, let's get to our first step of building our secure password checker. Now in here, I have a checkmypass.py file. You can do the same, and then I have my terminal right over here. What we want to do is initially import the requests module. If you haven't, well, then you can install the requests module. The request module is going to allow us to make a request. So remember, it's kind of like...
Wait. Pip install requests. I guess he refers to pip3 specifically. Requests. Oh, now it's a normal package, so it's already installed. Okay, no need.
The request module is going to allow us to make a request. So remember, it's kind of like having a browser without, well, the actual browser. We can just manually request something as if we have a browser and we get some data back. So the way we can actually use the request module with the password API is that we can have the password API URL, which I'll just tell you what it is. It's https://api.honedpasswords.com.
There is an extra T.
And in here, this is where we give it the password. So we can just do plus, and let's just for now do password 123. So that's the URL that we're going to use. Let's make this a little bit smaller, like that. Now in here, we're going to get a response by doing the requests.get, and let's just type this in and see what happens. If I save and run this program, and remember, we don't have the ability to type in the passwords yet, so let's just run the file. All right, so we get something, but it looks like an error. And that's because I did HTTPS. Silly me. But again, I want to show you that right here, I'm able to read the errors, and it looks like it's an invalid schema, no connection adapter for, well, HTTPS.
Okay, let's stop right there. Let's continue watching this.
Yo necesito la preventa del Sunbreak.
What?
Porque ese perrito Shiba Inu me está llamando.
Dale. Era eso. Bueno, la preventa de un Shiba Inu y un gatito.
Y un gatito. O sea, a ver, voy a ponerlo un poquito
para
que vean, es un gatito, creo que esto se llama cálico. Así se le conoce.
Los pálicos.
No, me refiero a la raza de gato que es así.
Ah, ya. No sé, el perrito le pusieron el Loyal Dog.
Claro, el perrito leal. Y así. ¿Pasemos a la siguiente noticia?
Ya, pues.
Ya. Porque te tengo que contar que...
Los Pokémon Arceus.
Que Pokémon Home va a ser compatible con Brilliant Diamond y Shining Pearl y con Legends Arceus.
What?
Sí, ¿para qué? No sé.
Sí.
Sinceramente.
Como que a cada rato. Mira, a mí me tinca, pero esto es algo así como que. Anótenlo, usted lo escuchó acá primero. Me tinca
¿Ya?
que con Scarlet y Violet, ¿sí?
Ujú.
Se va a abrir la posibilidad de que entren todos los Pokémon que están en el home. Creo yo.
Y eso serían todos los Pokémon, po, en teoría, así que me decía eso.
Entonces todos los Pokémon de Diamante Perla y de Legends Arceus.
Sí.
No todos, sino que todos los de estas dos entregas.
Pero en Brilliant Diamond y Shiny Pearl, ¿qué tenemos nuevo? ¿Qué hay nuevo? ¿Nada? ¿O sí? ¿Estoy olvidando de alguien?
Como nuevo.
¿No hubiera un Pokémon nuevo? Pues no, nada nuevo.
No.
Ah, ya. Eso.
Claro, podría ser que pasen esa generación que pueda pasar entera a Scarlet y Violet. Y por eso es que ahora son compatibles. Creo.
Pucha, o sea, a mí me encantaría que fuera así. O sea, la mejor noticia que nos podrían dar con el Scarlet y el Violet es que dijeran vuelve la Pokédex nacional. Y arreglamos un montón de problemas.
Sí, pero eso es. Como tú dijiste, lo complicado de eso es que el competitivo, al final del día. Porque en el competitivo se iban repitiendo los mismos que como una pool de 7
De
Pokémon.
25 Pokémon, digámoslo. Así, dejámoslo en 25.
Ah, ya, igual.
Porque están los counters de los counters.
Ah, ya. Entonces,
Ni una
de
tontera.
25 Pokémon y diciendo que ellos tienen 900.
No,
por
por más de
eso-
1000 si contáis la forma.
Sí, pero Pokémon en sí son como 900.
Ya.
Y aún así, sean 1000, que solo se usen 25 es un problema. Y es un problema que no le gusta a Pokémon de por sí. Y entonces entiendo por ese lado que no quieran abrir una Pokédex nacional, pero quizás tienen que encontrar otra manera de hacerlo competitivo.
Tienen que. Pucha, tienen que balancear a todos los Pokémon y ese yo creo que sí es un deseo. No imposible para ellos, pero va a ser un deseo. ¿No?
Y con
Equilibrar.
los ojos que son, y que no quieren gastar plata extra en nada, entonces no van a
Sí.
hacer.
Por ejemplo, como haces a Dunsparce, posiblemente competitivo, ¿cachai?
Claro.
Hay gente que usa un Alaron, pero de repente, como para hacer esas tonteras raras. Hay que arreglar muchas cosas. Yo creo que, no sé. Mira, por ahora lo único que te va a servir es que, por ejemplo, en Legend Arceus tenemos límite de tope de la granja, ¿cierto? Ah, pero te gustó ciertos Pokémon, los tiráis ahí y después los volví al Arceus. Eso lo puedes hacer. Eso es posible. ¿Ah? Igual pasarte Pokémon del Brilliant Diamond y Shining Pearl al Arceus también se puede.
Ya.
Obviamente van a haber limitaciones, por ejemplo, no vas a poder pasar ni al Zoroark de Hisui, al Pokémon Sword, ni al Chill, ni al Diamante y Pearl, y así. Van a estar como limitadas esas tonteras.
Entiendo. Entonces, por ejemplo, yo quiero un Shiny y es más fácil cazarlo acá en Arceus y lo mando al Home y lo mando al Brilliant Diamond y Shining Pearl y juego ahí competitivo.
Son más pasos.
Podría ser así. Y esto dejémoslo en tal vez porque también puede ser, ya lo que sacaste de Arceus son slots que andas guardando en el Arceus, porque recordemos que Pokémon Com es un servicio pagado que te da así como miles de cajas, millones de cajas,
Sí,
para tener a tu Pokémon guardado ahí.
sí, la verdad es que ese servicio lo encuentro muy caro. Así
Sí,
que
es carísimo.
no-
Yo cuando lo voy a usar, pago como el mes, lo uso, le saco todo el jugo y de ahí lo dejo pagar.
Claro, porque sale mucho más caro. Es como 3 veces la suscripción de Game Pass, más o menos. No,
What?
es eso. Ah, ya, pero es por un año.
That's
O sea, tan distintos
expensive.
servicios, pero por un año es carísimo. O sea, yo lo encuentro caro, el servicio.
Que yo recuerdo que al mes eran como $20, ¿no?
A ver, busquemos al tiro. Po. ¿Pero te has usado Pokémon Com alguna vez?
No, porque
Pero nunca, sí.
Nunca.
Mira. Al mes son $3.
Ah,
Ya, al año son $16. Tampoco tanto. Ah, sí,
no
no
era
sé.
tanto. Pero claro, o sea, pasar de los $5 que yo pagaba feliz por el otro Pokémon, ¿cómo se llama?
El que ya va a morir pronto, el Pokémon.
El Pokébank, claro. $5, saltar a 16, igual me dolió.
Sí, eso es verdad.
Sí, pero en algún momento voy a tener que hacerlo porque no he devuelto los Pokémon. De hecho, tengo que acordarme de hacer eso. Tengo que devolver a mis Pokémon a su respectivo juego. O si no, se van a morir en el limbo.
Van a morir en el tiempo.
No voy a dejar que pase eso. Pero sigamos con Pokémon.
Dale. Mira, ese nombre con estilo anda mandando salutaciones.
Saludos también.
Y el Gabriel Cake dice que es poco probable que pase la Dex Nacional. Sí, nosotros igual creemos lo mismo. O sea, si lo hace la gente feliz, pero...
Y ahora te quiero hablar sobre el Pokémon Unite.
¿Lo has
Porque
jugado?
no, llevo harto rato sin jugarlo, la verdad. Pero salió Espeon, así que quizás sea el momento de volver.
¿Será el momento?
Sí. Yo digo,
Bueno.
momento para volver, por lo menos a probar el gatito y de ahí dejar de jugarlo por 5 semanas.
Pues sí.
Bueno, la cosa es que, bueno, ya anunciaron Espion, sale, si no recuerdo el día de mañana, aunque tal vez ya está disponible ahora ya, por cómo se actualiza el Pokémon Unite.
Claro,
En nuestro caso,
PM.
sí, es un Pokémon de rango atacante, es decir, cumple el rol de atacante. Obviamente parte como Eevee, así que hay dos Pokémon que parten como Eevee.
Ujú. ¿Habrá una
Eso
manera
te-
de diferenciarlos?
Eso mismo quiero saber. O sea, posiblemente sean los ataques, tengan ataques distintos. Digo yo, los Eevee.
Claro. Igual como Eevee no duran mucho en partida, si es que farmean bien. Así que-
Acuérdate de que hemos tenido War Turtle hasta el
Sí,
último
pero-
los 2 minutos de la partida.
Sí, pues, pero piensa que ese es de 3 evoluciones, este es de
Sí,
2 nomás.
pero no, tiene que ser muy malo. ¿Te vaya a AFK?
Claro,
no sé.
o te olvidaste de moverte, o se te cortó el internet, pero hay que ser muy malo para no... Para
No evolucionar
al Eevee pronto. Igual, siento que la foto del espión salió tan mala. Así como, tiene tantos buenos ángulos y escogieron ese.
Ok, que veremos todas las evoluciones, las evolutions.
Sí, yo digo,
Ujú.
es que...
Y las nuevas, no entra.
Ojalá que haya una nueva, por favor, para esta nueva generación de Scarlet y Violet.
So if we run that again, all right, it looks like it worked, no errors, but let's print this out to see what we get. So print,
Yeah.
and I'm going to run this. And we got response,
Response
400.
400.
Now, a response or 400 is not good. Usually,
No, that's an error.
something's not right with the API. Now, these response codes are something we'll get into in the web development section of the course.
Yeah.
But it just means that 400 is not good. We want a response of 200. 200
Yeah,
is okay.
it's an issue that I
Is
have.
because this is not how the API actually works. You see here, we just created a password, but the way that this API works is it uses something called hashing. Now, what does that mean? I'm going to include a bonus lesson on
you're
this one so that
not
you can learn a little bit more about
passing.
hashing. But I have here this website that I'm going to link to, and let's make this a little bit.
You need to hash with a
It's a SHA-1
function.
hash generator. Now, hashing a password is something that you should always do. Let's say you're saving a user's password to a database. You should never store a user's password in what we call plaintext. That is exactly what the password is. Instead, you want to do something called hashing. That is, run it through a hashing algorithm to make it gibberish.
MD5
so when I use
maybe.
123 here and I click generate and I scroll down, this is the hashed password. Notice here that as I change this password, this changes.
Oh, nice.
But the key here, and this is something that we'll talk about in that bonus video, is that hashing is a one-way function. So there's many different hashing algorithms. There's MD5,
Yeah.
there's SHA-256. We're using SHA-1 because
This is
what this API is using.
destructive.
And SHA-1 essentially just hashes.
You
a
cannot
algorithm
recover
that does
the
this gibberish
password
output.
from the hash.
But no matter how many times we generate password 123, it's always going to be the
So
same hash.
it's going to
this
it's
way we can actually
deterministic
check if somebody
function.
types a
Yeah.
password, and we already have the hashed version of a password in, let's say, a database. We can actually compare the hashed version of this password to the database hashed password. Again, don't get too confused here. Hopefully in that bonus video, we'll cover this a little bit more. But the key thing is that this API, because we want to be as secure as possible, is, well, we don't want to send over the wire our real password. Instead, we want to send this hashed version of our password. So if I copy this and put it over here, this is what we should be sending to the API. But here's the problem. This is still not super secure because anybody can come now and type in and keep guessing, and eventually hit on password 123 and see, oh, this hash is the exact same one as.
Yeah.
So they will know that this is our password. So this API uses a technique called K-anonymity. And this is actually a modern technique that big companies like Google, Facebook, Netflix, Amazon all use.
That's new.
K-anonymity allows somebody to receive information about us, yet still not know who we are. How does this work? By the way, this is actually a technique that is used a lot, especially now where using personal data for companies is frowned upon. So ideally, you don't want to give your personal information to companies. So some companies that care about security and privacy use this K-anonymity to track you, but still not know who you are. Now, the way this works is that we only give the first 5 characters of our hash password. So 1, 2, 3, 4, 5. So if I remove this, what this API is going to do is it has a list of all the passwords that have been leaked. However, all these passwords are hashed with the SHA-1 algorithm. So it's going to look in its database of all these passwords and pick all the hashed passwords that have the first 5 characters that match this. So this way, with a response, we're going to get all the passwords that are hashed that have this. So that on our end, when we receive that response, we can check the rest of the hash function. This way, this API is never going to know our full hash and therefore never ever be able to guess our password. They'll just know that we have this tiny bit of a hash function that can match any hundreds of passwords. How cool is that? So if I actually save this and run, I get a response of 200.
Ah, success.
All right, let's take a break, learn a little bit more about hashing, and see you in the next video. Bye-bye.
Master the coding interview, data structures and algorithms. Okay, let's see the optional.
What is a hash function? It's something that's used all across computer science. A hash function is simply a function that generates a value of fixed length for each input that it gets. All right, what does that mean? Well, I have here a MD5 hash generator. MD5 is the type of hash function, and there's many, many types. You might have heard of SHA-1, SHA-256, and many others. Using this hash function, let's see what happens if I do hello. You see that right away, MD5 hashes this string and turns it into this gibberish. That's what a hash function does. We give it an input, and the function generates some random pattern. Now, there's some key aspects of hash functions. First is that it's one way, in the sense that if I give somebody this, they have no idea what the input was. And it's practically impossible for me to have any clue as to what the input is. The second is that no matter how many times I put hello in there, it's going to be the same. But as soon as I change one thing, it's going to completely change the output. If I go back to hello and watch me just change to capital H, even a capital letter, so it starts with 5D4. If I do capital H, it's completely different again. And looking at this, we can at least say that, I don't know what this is useful for, but the one thing that I know is that no matter what, if I give it the same input, it's going to give me the same result, but I have no idea how to convert this back into hello.
No.
This is what we call idempotent or idempotent. There's different pronunciations. I'm not really sure which one's which, but it is a fancy way of saying that a function, given an input, always outputs the same.
It's deterministic.
Now, the one benefit and why we would want to use this in a data structure is that we get really fast data access. Because all I have to do to find grapes, or basket.grapes, is to pass grapes into something like an MD5 hash. It generates this number for me, and I immediately know where it is in my memory on our computer. But this doesn't look like an address, does it?
No.
Technically, a hash function that we use for hash tables is going to take grapes, generate some sort of gibberish, and then convert it to an index space, or an address space that it has based on this number. You see, unlike arrays where we just had ordered indexes, with hash tables, all we need to do is give it a key and we know exactly where that item is in our memory. But you might be wondering, this black box hash function, doesn't it slow things down? Because every time we want to add a property and a value, grapes and 10,000, to a hash table, we have to run it through the hash function so we can decide where to put it in memory. And if you've noticed that, good job. That is a big factor. You don't want this to take a very long time because, well, every time you add a property to memory or retrieve a property to memory, because, again, at both times we're sending.
There is a call going on the job, so I guess I'm going to be pausing my learning here, and I need to switch back to my work computer.
¿Quién no está conectado en este momento? Levante la mano quien no esté
A
conectado.
la máquina yo me puedo desconectar. Pero
Okay, I got to go.